Data products represent a major inflection point in the maturation of information management. Most decision makers believe that a data warehouse is a prerequisite, but there's a new trend line reshaping the data industry, building data products without a warehouse. Find out more on this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Cavanaugh here. So excited to have an old friend back online. We've got Mark Madsen of Third Nature, and we have a couple folks who are going to talk about Matterbeam, which is one of the coolest technologies I've come across in a long time, in part because they took such a creative approach to solving a previously intractable problem. And we've seen in the data world, for example, that we kind of get into these habits of building big things. And I make analogies to the real world of very large buildings. And so like in New Orleans, in just a recent few years, they built a new VA hospital, which is this absolutely massive, honking, huge structure downtown. Absolutely massive. The air conditioning bill must be through the roof. You're talking millions of dollars to keep this thing air conditioned. And it's like, why did we do that? Why didn't we spend that money on MRI machines, for example? We don't need these huge facades anymore to administer healthcare. But there's an old mindset, and of course there are contractors who have to get paid and politicians who get involved. But in the data world, well, what's the analogy? It's the big data warehouse or the big data lake. And you have to wonder, did we learn any lessons from the data warehousing world as we moved into the data lake? And then, of course, there's the lake house architecture. And it's like, all right, guys, what are we even talking about now? Well, the folks who know something about that are Mike Kowalczyk of Matterbeam, and also we've got Josh Pendergrass calling in from Syncly. It's actually Broadmoor's Syncly company, and let's dive in. So I'll give my take of what I think you've done here, which I think is very, very interesting. So Matterbeam is focused on pulling in data from what are called write-ahead logs. And so every enterprise system of worth its weight in salt will have this write-ahead log. It's designed to persist data just in case the system crashes while it's in the process of writing to a particular system. So they said, hey, let's just pull all that. We'll get collectors. We'll pull all that into this big append-only log. And then they built a time machine that lets you go back, roll back in time, and sort of emit the data in whatever form you want. So if you want it for a graph database, fine. If you want it for a relational database, fine. If you want it for a vertically oriented, like a column oriented database. Fair enough. Whatever you want, you can do at the last minute. So as opposed to the old, if you build it, they will come argument, no, we're just going to create this giant append only log and then let users do whatever they want with it to do these last mile transformations and get data products on demand. I heard that. I was like, that is freaking cool. That is like really thinking into the architecture of how these systems work and finding a clever way to enable the possibilities down the road because you never know what's going to happen. And I'll say one last thing, just because this quote is in my head. We had a guy on the show about a month or so ago. They built a whole new ERP system. Sandeep Chopra is his name, from Everest Systems, and he said something that blew my mind. He said, "Why did we go with Agile in the first place?" And he said the reason is because no one knows what the customer wants. And so you just want to build something small and get your MVP and then be able to vet against the customer demands and kind of move incrementally out from there. Well, it's kind of like Matterbeam figured that out. And they said, look, we don't know what our users are going to want. We don't know what use cases will be down the road. So let's just allow them this quick and easy way to build data products on demand. So with that, I'll throw it over to Michael Kowalczyk. Tell us what you built and how it works.
Yeah, no, that's a great sort of synopsis of it. One other way to think about it is, I've been in engineering and data for a long time, and I always used to say that a lot of the systems that we work on are almost like fractal, right? You
Mhm.
work on something at a CPU level, and then you have distributed systems, and a lot of the same problems exist at the different layers. They're almost like look very similar. And that was one of the inspirations for Matterbeam, frankly, which is if you take, like you said, most of these relational database systems or any database system, frankly, usually internally it has this split of between how it writes its data and how it reads the data. And so to get data in fast, to make it durable and write it and all those things, you have the write ahead log or the commit log, depending on your system. And so you write all of that stuff, and then internally, what the database does is it turns that write-ahead log into your B tree in a relational database so that you can do flexible query. It turns it into the, key value store like things that make your indices and things like that. So all the different ways you want to read data inside of the database are basically materialized by the database internally off of this log, right? And this is also how read replicas and things work. You ship the log or whatever. But one of the inspirations was, well, what if you were to take that idea of this read write split and this write ahead log and blow it up to your organizational scale? And I have to give props to Martin Kleppman. He was one of the people that inspired me. I had been thinking about these ideas, but he really crystallized them. He had a talk called "Turning the Database Inside Out," where a lot of these ideas came out.
Hmm.
Um, but it's basically doing that, turning this idea that normally is like an internal detail of how these databases work, and turn it into a first class citizen of your organization. And now your B trees or your indices or whatever are actually full systems in a matter beam view, right? You make a relational database off of this. You make a graph database. You make a document store. You make these other things. And so it really does unlock a lot of incredible flexibility. I got to sort of prototype this at the company that acquired my last startup, and I really saw it completely transform how people engage with data, how they use data, how they even think about using data.
Hmm. That is absolutely fascinating. Let's bring in Josh Pendergrass. You're out there using this technology, and you've had a few aha moments along the way. I think you had mentioned before that at first you didn't fully understand what was going on. You just wanted to solve some problem, and then you were like, "Wait a minute, I now see what they're doing." Do you want to talk about that aha moment and what it was?
Yeah, so Mike talks about the immutable log, and at first I was like, that seems great. I don't know that I'll need that. It's more backup related, right? So I just need to move data from here to there for right now. But then as we got into it, the whole ability to replay something to any point in time or to sit there and transform it and emit it to multiple different sources, the hub and spoke sort of thing. It just the light went off on like, oh my gosh, as long as we're collecting this stuff, I don't have to worry about, setting a point in time where I want to connect this, and if I want to change anything, I've got to like go redo the whole thing, right? I can literally just make a change and it'll emit what I need and go exactly where it needs to go. So and the other thing is like, the key, once we figure that out, we decide we're going to dump all of our data in here and have it just always collect everything. And that way I can replay anything I want. I can create any report I want from whatever source I need. And so yeah, it was the immutable log now. First was not a big deal for me, and now I'm like, this is a game changer. This completely revolutionized how we do things.
Yeah, that's so interesting. And Mark Madsen, I'll bring you in. You've taught me more about database than just about anyone else I know over the years. And you know all about fine-tuning databases, which ones are better for certain use cases. And this approach I just think is so interesting because it's like it's going a layer deeper and enabling these last mile transformations to develop whatever you want. So, because again, you don't know what the customer is going to want. So, to get them halfway there such that they can just jump in and do this last mile transformation, that strikes me as pretty compelling. But what do you think?
Yeah, I think actually I would go the other direction. You said it goes a layer deeper. I'd say it goes a layer higher. Um, because the idea is that, you still have these databases and things doing their work, and we've always had them. And what I like to go back to the history of a lot of stuff we have and how we got there and why. And what's interesting is that if you go back to the mid 1980s, before and when the term data warehouse was coined,
Hmm.
we had big piles of production copies, but very specifically engineered for reporting. They mixed the two use cases. There was no separation of concerns. And so everything was always collect and smush. And then you had your rectangle, and then you went off and did your report, which is ironically no different than today's, pipe my lake to Power BI and Tableau things where people do what Michael criticized as the point-to-point pipeline. Every report is an object, is a data product, whatever you want to call it, is a pipeline. That is a non-starter and a non-scalable model. And he focused in on that, I think, as design principle. But the other part about moving up is Back in that 1980s, if you go back to the very first paper which ever used the term data warehouse, it actually separated out collection from integration. And what we're doing here is we're saying, look, the old architecture was, had this for reasons of convenience, for ease, for cost. We did something different and we put it all into one system box when we shouldn't necessarily have done it that way. And inside that data architecture was collection, use as two separate domains. And what we're talking about here from the description of what Josh is doing and from what Michael is talking about from a tool perspective is how about we separate those again? I'd kind of like to hear, your guys' opinion on that because that's my observation.
Yeah, I
Michael,
think
go ahead.
yeah, I think that's a good observation. I think it's trying to separate those concerns because I think a lot of this trying to smush everything into one system is a little bit historical and it's not really serving us now, right? One of the reasons we have the lake house now, right, is because everyone went in all on the warehouse and they're like, oh, actually, this is terrible for distributed compute. Or the other side of people who went all in on Databricks or some distributor or Hadoop or some distributed computing. And they're like, oh, this is terrible for warehouse jobs. So now we need the new one giant system to smush everything into, and we'll call it the lake house. And it does either okay, but not great, right? I'll give you props too, Mark, that one of the other things, I mean, 10 years ago now, that inspired me a little bit in Matterbeam was one of the talks you gave at a GoTo conference where you made this specific, I mean, the talk kind of goes in a lot of different directions, but you talked about making explicit trade-offs, right? There's no one system that will do everything, right? You're going to make trade-offs on how your physical schema is and your logical schema is and how you represent the data changes what you can do with it and your sort of write and read characteristics. And so what if you could move those trade-offs upstream, move left, shift left, or whatever, and so you don't have to make those trade-offs right away. You could do them at the moment of need and put them into those systems and take advantage of the best of breed thing at that time. So I also like to look at the history of things, and there's so many brilliant ideas that have been woven through the history that either fall by the wayside or people rediscover and they're like, oh my God, I discovered this new thing. You're like, actually, that's that thing from 1985 or 1990
Yeah.
or whatever.
Yeah, I totally agree too. I think of it from a time to implement, right? So if you don't separate concerns, I've got to think about all the starting points, all the stuff in the middle, and then getting to the end. Whereas if you separate those, the collection of these things, that data usually doesn't change, right? That's kind of the same. But what changes is what comes out the other end. So if we separate those concerns, I can focus on just the last part of it. And we've noticed that where things are much easier to implement because we've got the data, we change the shape, and we emit it out.
Yeah.
Yeah, and
I
there,
mean,
there was
one
an
of, oh, sorry. Sorry, Michael.
I was gonna say one other interesting thing. I mean, I witnessed this at the startup that I was at before, but then I saw it happen at Syncly Broadloom as well, which is being able to emit and flexibly transform allowed them to iterate, right? They didn't have to big bang have the design up front of what the shape was. They could try a shape. Oh, that's not quite right. Let's rewind. We'll do another. Oh, no, that's not quite right. We'll rewind. And oh, this one works. We'll keep that one going.
Hmm. Yeah, that makes a lot of sense. What I think about the evolution of our industry, I remember going way back when, 20 years ago, when I was at TDWI, I interviewed a guy named Dr. Michael Stonebreaker, and I didn't know who he was at the time. And my buddy Philip Rustin was like, "Whoa, you interviewed Stonebreaker? He's the godfather of the modern database." And at that time, he was pushing a mantra of one size does not fit all. And his point was that at that time, relational had won the battle, and every database everywhere was relational. It didn't matter the use case, analytics, operations, whatever, who cares? It's all relational. He said, no, that's not good. You want horses for courses, as Jim Erickson used to say, meaning he had a vertically oriented database called Vertica, curiously enough. And he said, this is better for analytics for a couple different reasons, one of which is the columns all have the same kind of information, so they compress better and you can do some interesting things. But like over the time, you see this evolution. And after that, like my goodness, the next 15 years, the database space exploded. And there are now like what 429 different databases or something. You got graph, you've got vertical databases, you have object databases. You had the whole Hadoop thing, which was a very interesting left turn that the entire industry took. And I think we learned a lot of lessons from that. But still, Hadoop is like, okay, what did Robin Bloor say? It's a really slow database. That was his assessment. But
And now
you know,
it's
Mark, I'll throw
Iceberg is a really slow database.
right now but it's very slow, but it's like, oh, you can layer it over all this other stuff, and now you can bring it together
Right.
slowly, right?
It is funny how well, Michael actually got me thinking about how, you know, as engineers, and I'm a recovering engineer still, um, you always look forward. So you're always taking what you have at hand and trying to build forward without looking back very much. And it's not just the tools, right? You could look at Hadoop and say it's a tool. It's what pattern does the tool enable? And databases enable certain patterns, and one of them is that databases hold their data dictionary inside. And so if you exceed the carrying capacity of one database, you're kind of stuck. Now you need two databases, but what happens? Well, sales live in one and customers live in the other. Now what do I do? I think we're rediscovering that in the so-called lakehouse pipeline architecture, where you end up with a data product. I guess that would be the meshy term. Here's the data product for customers, and here's the data product for sales. This was the Hypercube problem pre, 1988, pre-data warehouse, and you need to enable remixing more easily
Mm.
at multiple levels along the way. I think we should talk about some of the architectural considerations that happen when you try to construct something that makes reuse or remixing really easily. And I think Josh should have some insights on that.
That is interesting, and I'll just throw out one comment here to close out the segment. I remember when the NoSQL movement began, and first of all, it was no SQL, like we don't need SQL, and then it was not only SQL, right? So like even the definition of that acronym changed. But then what did you see? Hadoop came out, everyone's like, oh, this is going to solve the world's problems, even though, MapReduce is pretty arcane and has certain good use cases, but not many. And I remember scratching my head thinking, this doesn't make a whole heck of a lot of sense. And then what happened after that? They said, oh, yeah, SQL on Hadoop. Let's go ahead and slap a SQL layer on top of this Hadoop architecture. And it's like, it doesn't take a dyed-in-the-wool engineer to figure out that gets a little kludgy, a little complicated. It's going to be not the most efficient system that your engineers have ever cranked. And we had an interesting question come in from one of our virtual attendees here, part of the virtual studio audience, asking how would that be different from a Parquet file? I remember when Parquet files came out. It's a very clever idea because you kind of built in, it was designed for analysis basically. And you had this little, if I recall correctly, you have a little block at the very top of the file that has like min, max, and some basic information to be able to find it and align it with a particular query. But maybe, Michael, I'll throw that over to you.
Yeah, actually, this is one of the sort of soapboxes I get on a lot, which is Parquet is really cool, but it is definitely a physical format designed with a certain kind of query in mind, right?
Hmm.
Analytical queries. It is a columnar format. It's designed, it's schemified. It has all those characteristics. And if you want to do analytic queries, great, right? Use Parquet. But if you want to do anything else, if you want to run, transactional things, it's not so good for that. If you want to do other things with that data, it's not so good for that, right?
Right.
So, so I keep pushing back against this idea of the one thing to rule them all, right? The one format, the one system, because it disregards the engineering trade-offs that are made for that system and for what it was designed for, what its purpose was.
Hmm.
Yeah,
Josh, you want to comment on that? Or go ahead, Mark.
yeah, that's definitely the thing is the trade-offs, right? And you think about the history of that, it was, oh, everybody's writing text, and a lot of it was ASCII log text, not even UTF-8 text, into Hadoop clusters. And then people were saying, oh, well, to have to parse that, there's no control over it. What's in that column? Oh, there's a comma missing. Now all your columns are misaligned and you don't have data anymore. You have garbage. So what if we impose some constraints on that, which, suddenly schema on write, comes back with a vengeance because of all the garbage data we recorded. And then it's like, well, we have that, but it's inefficient, right? So we need a binary format because what you're doing is taking text and turning it into numbers and then turning the numbers back into text when you query it, and that's stupid. So let's make Parquet. But of course, they went with all of the, sort of Java world data types, but not all of them, and kept it really simple. Here's some integers and here's some floating point numbers, and God help you if you have date times. And then, what happens, like Michael said, is, oh, well, it's not good enough for transactions. Well, transactions weren't important because it was for analytics. But if it's for analytics and you're just supposed to read Parquet by scanning the whole thing, number one, you don't have indexes, so you can't look up one customer without scanning the whole mess. And number two, what if there's a mistake in the data and I need to fix it? Well, then I got to update it. But updates in there are very messy. And now suddenly, while Michael's reading what I'm fixing, he gets the wrong answer. Now what do we do? Because the answer today is not the answer yesterday. Oh crap. And now we have iceberg. Now we have delta. We're just rebuilding the past because nobody's bothering to look at that without looking at what problem are we trying to solve. And in this case, transaction world lives on one side and generates data. Analytics world needs that data in different ways, integrated differently with different views, and has to be remixed, possibly retyped and joined across two different systems from the source, which means you've got to do work on that data, which is how we end up with data products, data marts, and everything else. And so
Mhm.
I like separating those worlds, which is why we had data warehouses. But then you have to take the data warehouse and say, what was it for, and break that down. And it was for the stuff we all agreed on. Everybody says this is what we mean by margin and this is what we mean by product cost. But what if Josh comes along and says, yeah, but I've got two different companies that merged and they measure their product cost differently. Now we need to have product and service costs separated. Well, somebody's got to figure that out. How do you do that? Well, you got to go back to the source data and start over. And I'd kind of like to hear, Josh's opinion on that because he's, the guy who owns the stuff that's trying to do exactly those jobs.
Yeah, yeah, we've definitely seen benefits there where we have companies we've acquired that do this a similar thing. So we're working on this right now, actually, where we both are collecting similar data, and we need to basically aggregate that and push it out to a common format so that we can report on it no matter which customer you came, no matter which company you came from originally. And to do that, the other way would be try to figure out all these things, get pipelines going, and then or dump everything, create views, or a lot of different ways to do it. But with Matterbeam, it's like, okay, we'll just start collecting that stuff. We'll go back in time, collect all of the stuff of theirs. We know what the shape is that it needs to be, and we'll emit it, right? So um, and it's the other thing too is like we have sources coming in from everywhere. We've got all kinds of different, we've got different databases, we've got API endpoints that we hit to collect things. And so all of those get aggregated, and I can't tell you how often we need the same source over and over again. I never thought about it like that, when it's like, okay, you build it from start to finish. But when you go, oh, I've already got that. Oh, we can just pull from here and combine these and spit this out, right? So it becomes so much easier.
Hmm.
Yeah, there's another piece to it too, which I experienced in sort of previous life, but it's okay. You've got this sort of crystalline thing that's the dashboard, the monthly active user, the whatever. With this model, what you can do is say, hey, we need to tweak it in some way. Let's make a parallel view. Let's replay all that data with just these tweaks, with these additions. You don't disrupt the original dashboard. You create the second view, you migrate over. It makes that infinitely easier. I have this story about when I was in an executive meeting and there was an acquisition, an acquisition came in and the CEO was like, we want to change the monthly active user. And the head of data in the meeting was like, that'll be 6 months. And he's like, how is that 6 months? We have the data, don't we? Doesn't this data exist? And it was not, it's all these pipelines and structured things like that.
Wow.
I used to be an analytics director, and one of the things I think you mentioned a while ago was just what's your backlog? And that was the joke. Yeah, we built a data warehouse. I've been an expert. I worked, with Bill Inman. I worked with Ralph Kimball and the Kimball Group. I built like, I don't know, close to 50 of the damn things, and there's always that emphasis on stage one, which is get everything out there, and then people are happy because they've given you the requirements. It's about the reusable data that everybody agrees on. And then you start to get to the smaller requests. Well, the sales guys want to look at this stuff, but sale, according to generally accepted accounting principles, is left the loading dock. But sales to a salesman is when you booked the sale, and the commissions at that company are paid not when it's shipped, but when the sale is actually booked. And so you can't use the exact definition in the warehouse that everybody's agreed to for what's a sale. You've got to go one level below that to define the rule of sale,
Yeah.
right? So you actually need something slightly lower than what would be considered for 99% of actual reporting. And
Yeah,
that's what
I was,
leads to all the backlog.
yeah.
That's
Well,
the thing.
I love you brought that up because that's another inspiration for Matterbeam is domain-driven design, right?
Mhm.
The whole idea of the one of the reasons why we store the data in this immutable log that's source aligned is that we keep it in the domain of the person that we're collecting the data from. And if you ever get into the domain design driven sort of literature, like the way things are supposed to happen is that domain language is transformed between domains when it's emitted to or used in these other areas. And so we surface that. The idea is I could take that stream of doc things or whatever, and I we can coordinate and I can turn it into the sale version that makes sense for my domain, right? In that last mile, instead of having the one universal, data model for everything, which we all know never works. People fight, you get one and it's got all the null fields because nobody can fill in all the fields and whatever. Instead, you let people operate in the domains that they do their work in, and now you can do this translation between them at that last mile.
Mm.
It's an interesting point, but there is a problem there, and it's kind of why data architectures are, more than two layers, because that there is stuff you have to agree on. I don't think we should get rid of data warehouses because they're for the important stuff you have to agree on or you can't work. But there's a lot of stuff that you don't know that becomes important that needs to be promoted there.
Mm.
And
Yeah.
this part of the architecture, both the fabric to get data where, it's collected and usable, but it's not, or it's collected, but it's not necessarily usable for that final thing. The domains that you're talking about to me are interesting in a different way, which is that from an operational perspective, there's the domain of the generator of data, the order entry system or the CS system or whatever it might be. The domain of analytics is a different domain because it's typically not about task execution and managing a task with local data. It's about managerial oversight of business process that crosses systems, which requires data from more than one thing. And so that is a domain in its own right, but you can't easily meld those two back in operations land. So you always need a boundary zone in between that allows you to do that remixing.
Yeah, absolutely. And it's funny because some people, when I've talked about this, are like, "Oh, so this does it automatically?" I'm like, "No, it does. You still need people, and you need to make those agreements and
Yeah,
move things across. But it gives you the tools to make that
yeah,
easier, right? To be able to replay it, change the shapes, and when things go wrong, when you're like, "Oh, actually, this sales thing isn't what we thought the sales thing was." This immutable time travel thing allows you to heal, right? Which is not a characteristic of most systems today, right? You can go back and
right.
say, let's take a different view and replay that in, and now we've now created a new agreement.